Hello guys, welcome back. In this video, we are going to cover the basic fundamental concept of Java that is called method. So by the end of this video, you can able to understand the concepts of method as well as you can able to implement the method in Java program. So in general, we can call this as a collection of statements that are used to perform a specific task. So that particular method, whatever the methods we are writing here, that particular method will use it to enhance the code reusability. That means what? Whenever we are writing the code, or instead of repeating the same code and again, we can include or we can incorporate that set of statements which are to be repeatedly executed or which are to be repeatedly used in a particular method. That means for a group of statements, we are going to assign one name. Whenever we need that particular group of statements, we are going to use that particular name instead of writing the same code. This will overcome the problem of writing the same code for multiple times. So whenever we are writing the method, we need to declare that particular method. So the method declaration provides information about the various attributes which are used in the method, like from where we can access that arguments or from where we can access that method and from to where that particular method is going to send the result and name of the method, how many arguments we have. Like this, there are total 6 components are there in that particular method. So we can call this as a method header. Then list of arguments I'm writing double comma double, like this we can write here. So we are going to consider this entire thing as a method header, which includes access specifier and return type, method name, and list of arguments. 2 arguments we are passing. Like this, we can pass any number of arguments here. We can write any return type like integer, character, float, double, boolean, like this. And this is the access specifier. Any access specifier we can write here: public, private, protected, like this. And whenever you are writing, we can call this entire line as a method header here. And if the method name along with the arguments are called the method signature, these methods will provide the code reusability, and it enhances the modularity as well as the readability. We can divide the program into any number of pieces here, and each and every piece we are going to call this as a module. So these modules are used for better readability, and it can return a value to perform that action, any kind of action it is going to perform here. And we can also include some set of parameters, and these parameters are going to be operated inside the method definition. Predefined methods are the methods whose definition is already available with the compiler, so no need to write any definition for this here. So whatever the definition we have with that compiler, that definition we are going to use just by calling that particular method. So whenever we are using predefined methods, without defining the method definition, we are going to use, because the definition is already available with the compiler. So the definition which is available with the compiler, we are going to use just by calling that corresponding method name. For example, if we have methods called print, right? So we are using one statement called print here, let us assume. So print is a system defined method or built-in method which is coming from the class called java.io.printstream class. So from printstream class, we are going to use the method called print. In the same manner, we have a method called square root, we have a method called equal, and we have a method called length, we have a method called compare. Like this, there are various system defined methods are there. We can call it as a predefined methods or built-in methods or system defined methods. So if we take this example, for example, the class name is student here. I'm writing the main method. I'm defining one variable here, double number equal to 25, and also I'm writing a statement called double result equal to math.sqrt of num. The sqrt is the method which is already available with the compiler, so we can use directly without defining. There is no definition we are writing here for sqrt. So math.sqrt num. So whatever the number we have, that number we are passing into the predefined method called sqrt. So it will find the square root of that corresponding number. I want to print that number, for example. So when we run this, as you can see, the square root of 25 is 5. As there is no definition for us, like this we can apply any built-in method. So when we come to the second method called user defined method, the name itself suggesting that the methods which are defined by the user. When we come to the third parameterized method, the method with the parameters. We are defining the method. That method should have some list of parameters here. If we take example for the parameterized method, as we can see here, the method name is add number, and this is the user defined method. And in this, we are passing 2 arguments here. The type of 2 arguments we are passing, the type of arguments are integer. So integer A, integer B. Writing the method called add number with two parameters are that two parameters are of type integer, and then c is equal to a plus b I'm writing here, return c I'm writing here. Then main method, then also I'm calling the method called add numbers 5 comma 10. So we are passing 5 and 10 to a and b, and then I'm adding a plus b. That result is I'm storing into c, then I'm printing the value of c. So when we run this code, as you can see, the sum is 15. So with parameters. So the next is called method with return type. So same example I'm using here to have the return type. Just I am removing this line here. So I'm keeping in comment line and I'm writing return a plus b. So when it is returning, we need to have this particular method is returning integer value. So that's why I'm specifying the return type as integer here. Then a plus b, this line is also not required. We are returning that corresponding output from where we are calling here. So here I am writing system.out.println output statement I am writing, as we are assigning the result to sum. So I am writing sum equal to. So sum is not declared here, integer, sum equal to add numbers. This is the example of method with return type. So we are going to have return. So the whatever the sum we have, that particular sum is returned back to from where we are calling that corresponding method. So as the result of this method will be stored into the variable called sum here, and we are printing the value of sum. So the same output we are going to get here. Parameterized over, method with return type over, then method overloading as well as method overriding. Here we are using method overloading. It allows multiple methods with the same name but different parameters in the same class. So we are going to use multiple definitions for the single method, but only each and every definition is going to vary on the number of parameters as well as the type of parameters. For example, if you see here, the class name is student here, and I'm writing one method called add with two parameters of type integer type. So I'm writing return a plus b. Then here also you can see the method name is add here. Method name, same method name we are using here, but instead of two parameters, we are taking three parameters are of type integer type. Like this, we can write any number of definitions. For example, here I'm taking integer float or integer float integer, like this. Multiple combinations we can write with the same method name. So even though the method name is same, and the number of parameters and type of parameters are going to be modified here. Let us assume I'm writing one more method. So static float add float a comma integer b. That means we are going to add float as well as integer values. So in that typecasting as well as type conversion is required. So like this, we can have any number of definitions within the same program or the same class. But the only difference, how we are going to differentiate, how the compiler is going to differentiate the both the method definition means based on number of parameters and based on type of parameters. So just for our simplicity, I used here one method called add with two integer parameters and another method called also add with three integer parameters. So whenever we are calling the add method with two parameters, this corresponding method is going to be called. Whenever we are calling the method called add with three integer parameters, this corresponding method is going to be called. So let us take here main method I'm writing here, add 10 comma 20. So add is the method here. How many parameters we have? Two parameters. So the method with two parameters will be evaluated here. So integer a comma b. Then 10 is passed to a, 20 is passed to b, return a plus b. So from where we are calling this corresponding into this corresponding place, it is going to return the result. So return a plus b is 10 plus 20, that is we are going to get as 30 here. In the same manner, the second method we are calling add 10, 20, 30. Three parameters we are passing here. So this corresponding definition is going to be called return a plus b plus c, 10 plus 20 plus 30. Result as 30 as well as 60. So like this, we can call this concept as overloading. Instead of writing multiple methods for multiple definitions in Java, we have a facility called method overloading to overload the definitions. That means what? The method name is same, but the number of definitions we can write here, and the compiler differentiate these definitions based on the number of parameters and type of parameters. So next, method overriding. So the basic difference between method overloading and method overriding is, in overloading we can have multiple definitions for the single method name, but in overriding we are going to override the old definition with the new definition. So in general, the overriding concept is used whenever we have multiple classes or whenever we are inheriting the properties of one class from another class. We have a class called parent and which we have a simple method called show. Just I want to display some message here, parent class method. In the same manner, I'm going to write one more class here, class child, which is extending the properties of parent here, And here also I'm writing the method called show. As the method name is same and the method name in the parent class and method name in the child class is same. And also we are acquiring the properties of parent here. As if you are not extending the parent, we can create one object for parent class and we can create object for the child class. And with the help of that object, we can access the members of parent or members of child. But as we are extending the properties here, as we are inheriting the properties of parent here, with the help of the object what we created for child class, with the help of that particular object, we can access the members of child class as well as the parent class as it is inheriting the properties. So whenever we creating object for the child class, with the help of that object, if I am writing object name dot show, the compiler may confuse that that particular definition has to be accessed from either child class or parent class. So to overcome that particular problem, I am writing the keyword called override here, which I am giving the instruction for the compiler override the previous definition. Whatever the previous definition we have here, this definition is going to be overridden with the child class definition. Likewise, so whenever we are inheriting and whenever we have a same method name, in that case, the compiler is going to override the previous definition. That means if we have a same method name in the parent class as well as child class, the child class method is going to be overridden with the parent class method definition. So whenever we are calling the method name, only the child class method is going to be called and the child class method is going to be operated. It is to produce the corresponding result. And here the class name is student here, main method I am writing. As we are overriding here, the compiler can understand that the previous definition can be overridden with the new definition. As this is a new definition here, this method is going to be the show method from the child class is going to be executed. So let us run this code. As you can see, this method is going to be executed. Child class method overridden. The recursion is nothing but calling the same method from its own definition. So when you are writing the definition, from inside the definition, we are calling the same method name. That is, if we have a method called ABC, in the definition of ABC, we are calling the method called ABC again. So the same method is going to be called by itself, then we can call it as a recursion method or recursive method. If we take example, as the class name is student here, then I am writing one method called factorial integer n. We are passing one argument here. So this is called parameterized method. In general, if n is equal to 0, return 1 I am writing, as the 0 factorial is 1. Else, we are going to have written n into factorial of n minus 1. If the n value is 10 here, what we are going to write here? N value is 10. It will check 10 equal to 0 or not. False. So it will come here. So 10 into factorial of 10 minus 1. What is 10 minus 1? 9 here. So 10 into factorial of 9. That means what? We are calling the method called factorial, or we are calling the function called factorial by passing the value called 9 here. So 9 is passed to here. That means now n value is 9 here. Again it will check 9 equal to 0 or not. No. So then 9 into factorial of 9 minus 1, 8. Factorial of 8 again factor. Like this, the same repetition will be continued until the value of n is equal to 0. So when it is equal to 0, it is going to return 1. That means the first value, in first iteration we have a value 10 here, into second iteration we got 9 here, 10 into 9 into 8 into 7, like this up to 1 we are going to get. So whenever it is 0, it is going to return 1, and when it will multiply all the numbers then to print the factorial. Here in the main method I am writing integer result equal to factorial 5. I am calling the method called factorial by passing the value called 5. 5 is passed to here, and the same process will be repeated. We are going to print the result here. Let us see. 5 factorial means 5 into 4 into 3 into 2 into 1. We are going to get 120. So the factorial of 5 is 120. Java, apart from the method types what we discussed till now, there are another 3 kind of important method categories are there. One is called static method, and the second one is called abstract method, and third one is called instance method. In general, whenever we have a class, if you want to access the members of one particular class, we need to create object for that class, and with the help of the object we are going to access all the members of that particular class. But whenever we have a static class here, for that particular class, no object is required. We are not going to create any object here because it is a static class. So without creating object, we can access the members of that particular class. When we are declaring the static keyword and can be called using the class name without creating that corresponding object. So no object is required here. Simply I am writing here class name dot that method name. For example, if we take this class here, the class static demo, my class name is static demo, and here I am writing a static method that is called static integer square. I am writing integer x. I want to find the square of that corresponding number. For that, I'm writing the static method here. Then I'm writing one more class called student here, and this is the main class and main method I'm writing here. Result equal to, as you can see, result equal to static demo dot square. In general, when you are if you want to access this method from outside the class, we need to create object for the static demo, and with the help of object name dot that corresponding method we need to write here. But as this particular method is static here, instead of writing the object name dot method name, we are writing the class name dot method name. We are writing static demo dot square is a method. I'm passing 5 here. 5 is passed to x, and it is going to return 5 into 5, 25, and the 25 is passed to the result here. We are going to print the result. The basic characteristics of the static methods are, whatever the method we declared as a static, that method belongs to a class, not an object. That means we can access the methods with the help of the class, but not the object. And these static methods can be called using the class name, as I said now. And we cannot access instance variable directly. Whatever the variables we declared as instance variable, that variables we cannot access directly from the static method. And it is not possible for us to use the super keyword. We will see later what is super keyword. So whenever we have a static method, we cannot use the super keyword. And we can also access only static variables as well as other static methods inside that particular method. So whenever we have a static method, that static method can only access the static variables. Then when to use these static methods? When the method does not depending on the instance variable, that means whenever the instantiation is not required, we can use static method. And when we are performing the utility operations like mathematical operations by using built-in methods, in that case also we can use static method. And when we are defining constants or when we are defining helper methods, in that case also we can use the static method. If we take instance method, in general, instance, the name itself suggesting that we are going to create an instantiation to access the members of that particular class or to access that corresponding method. So an instance method is associated with an object of that particular class and operates on instance variables only. It does not use the static keyword. So these methods belongs to instance of the class, but not directly class. If you want to access the member, we need to create an object here. And if you want to access that corresponding method definition, it requires an object. We need to call the object. With the help of that object only, it is possible for us to access the corresponding instance method. So we can access both static as well as non-static variables in the instance methods. Wherever required, it is possible for us to modify as well as access. And we can use this keyword to refer the current object in the case of instance method. And if you want to access the method, we need to have an object, not the class. It is not possible for us to access directly the instance method with the help of a class. If you consider the example, the class name is instance example. I'm writing one variable, string variable, that is called model, string model I'm writing here. Then instance example, here the class name is instance example and method name is also instance example. That means we can call this as a constructor. So we'll discuss later again. The constructor means whenever an object is created, this is the default method which is to be executed by the compiler. I'm writing one more normal method, display model. So I'm printing some message here. Then main class I'm writing student main method. Then I'm going to create two objects here, car1 and car2. So when this car1 is created, this corresponding constructor is going to be called Tesla model S. So this Tesla model S is passed to model and model is passed to this dot model. That means what? Which is referring the current object here. Then in the same manner, car2 object also we are going to have BMW X5. Then car1 dot display model, car2 dot display model. So object name dot method name. This is a user defined method I'm writing here. So car1 dot display model, this corresponding method is going to be executed. Car2 dot display model, this corresponding method is going to be called by passing the argument called car2. So for car1, this message is going to be printed, and for car2 object, the second message is going to be printed here. If you observe the output here, as you can see, it is going to print the output. Car model equal to model, and for car1 and car2 is equal to BMW. So when we come to the abstract method, the abstract method is a method that does not have any body. We are not going to implement any definition when the abstract method is called. So without body, we are going to write that corresponding definition, as we are using the concept of overriding to write the definition outside the class. So it is declared using the abstract keyword within the abstract class or an interface. So here, when we are going to the abstract class example, as you can see, the class before the class name, I'm writing abstract here. So the basic syntax is abstract class, class name, and I'm writing the abstract method here. So abstract class and abstract method. As it is the abstract method, abstraction means hiding, data hiding here. For that, what I'm going to write here, whatever the method which is declared as abstract method, we are not going to write any definition. Simply I'm writing the method name and then close. There is no definition here. Then this is a normal method, sleep, and also I'm writing one more class called class dog extends animal, and whatever the method name we have in animal class, the same method name I'm writing in dog class also. We call my dog makes sound as the same method name we have in parent class as well as child class. So as we are applying the concept of overriding, it will override the parent class definition with child class definition. So my dog makes sound. This particular message will be displayed here, dog dot sleep. So sleep method is going to be called. So when we run this code, as you can see, these two are the messages what we got here. Compare the static as well as the instance and abstract methods. As you can see, the static class belongs to class. We can also call this as the class method, and the instance method belongs to an object. With the help of object only, we are going to access the instance method, and the abstract method will belongs to abstract class. As there is no definition here, we are going to hide the definition of that particular class. Requires object. For static method, no object is required. For instance as well as the abstract method, we are going to have an object here. So access instance variables. We cannot access instance variable in static method, and we can access instance variable in the instance method as well as in abstract method. Can be overridden. We cannot override the static method, but we can override the instance method as well as the abstract method, as it is mandatory for the abstract class. Overriding is compulsory. So can be static, yes, and in the case of instance method, it should not be static, as well as in the case of abstract method also, it should not be static. How we are going to implement? We can implement the static method, we can implement the instance method, but we cannot implement the abstract method, as we are only declaring that particular method and we are implementing outside the class. So when it is used for, whenever we have a utility methods like predefined methods, we can use this static method. Whenever we have an object specific behavior, we are going to use instance method, and whenever we have an abstract behavior, we are going to use abstract method. So this is about the various types of methods which we are using in Java. If you consider the summary, you may have some, you might have confused when to use static method, when to use instance method, and when to use abstract method. But the basic funda, whenever the method does not depending on the instance variable, when the method does not depending on the instance variable, whenever we are performing the operations with the help of predefined methods like square root, power, and print, like this, whenever we are using these kind of operations, we are going to use the static method. And whenever we are defining the constants, and whenever we are defining the helper methods, 4 cases we are going to use the static method. If we consider the instance method, when to use the instance method? When we are working with object specific data, or when we are modifying the instance variable, when we are implementing the behavior that varies between instances. In these 3 cases, we are going to use the instance method. If we consider the abstract method, whenever we are designing the base class, to declare a method but not define, we need to define or we need to implement the corresponding method in another class or in subclass we can call. When we are following polymorphism and abstraction principles in OOPS, and also when working with interfaces or the abstract classes in frameworks. In these 3 cases, we are going to use the abstract method. So I hope I covered everything. That's all for now. If you have any queries, comment on me so that I'll try to reply. Thank you. All the best.